Hey, what's up everyone, and welcome in a new video. We continue our crash course about Kubernetes, of course, and today we will discover volumes, so with a new part with persistent volume, so this is what we named the PV, and the PVC for persistent volume claim. So this is really important things inside the Kubernetes, how to persist your data. So this is really important to well understand this part, to be sure that you can deploy everything where you need to be stateful, like database, but also like static things inside some website, for example. So let's go. This is a theory section in this video, and in the next section we will discover a little demo to try to use what we will have discovered today. The first thing, concept. So you have 4 things that you will discover today. The first one is persistent volumes. The second one is the persistent volume claims, of course, and we have 2 other things that we will to discover today. The first one is the storage class, really important things to well known. For example, when you use a cloud provider, you use in not every use case, but in many cases you will use a storage class for sure. And another one is the provisioner. What is a provisioner, and what is the kind of thing that can bring by the provisioner. Let's go. First one, persistent volumes. What is it? Imagine that you have 2 roles inside Kubernetes. The first one, you have the administrator, and the administrator, like the name means, administer the Kubernetes and manage the Kubernetes cluster, of course, and can handle some part of things like disk management, like disk provisioning, and want to manage this part of things inside the Kubernetes cluster. Of course, it's like a physical server or virtual server. You need to do that for sure to manage the disk size and maybe resize the disk, etc. This is exactly the same thing inside the Kubernetes cluster. But we can consider this is totally different, totally independent about the pod management. For example, a developer, so this is a second role inside Kubernetes. A developer or a basic user inside Kubernetes cluster need to provision some pods, and of course need to use the disk provisioning, and the disk provision need to use it to store some data like statics or databases. And you need to consider that we have these 2 kinds of roles. The first role, so the administrator, manage, for example, the persistent volume. The persistent volume is where the administrator can set or manage the disk size, or basically the persistent volume. So this is the disk volume provided by the administrator for the developer. He can adapt many things in the backend, and the user doesn't see anything about all things that the administrator manage inside the backend. For example, what happened when the pod is destroyed and you will lose or removed the persistent volume claim, for example. What happened? You don't want to take care about that. This is the role about the administrator, and the persistent volume can provide and allows the Kubernetes administrator to manage this kind of thing. There is also some stuff, some specification about the persistent volume, and persistent volume, of course, is a basic resource inside the Kubernetes cluster, and you can set some specification inside the manifest, like a pod or other things, and you can set inside these specifications the retention policies. For example, if you want to delete the content of the persistent volume claim, so basically that means that you can lose the data in the final step if you want to retain the data or just to recycle the disk. Another thing that the administrator need to take care is the access mode. If you want to mount read-write once, but it's not on pod side, it's on the node side. That means if the administrator, not only you, but the administrator set the persistent volume to read-write once, that means that this volume can be mounted more than one time on a single node, not on many pods, but on single node. That means that this volume is just mount one time. You have, of course, the read-write many, so you can mount multiple times the same volume on one node, for example, a worker node inside the Kubernetes cluster. Okay, the second concept, so persistent volume claims. Now we switch our role, and we are, for example, a developer, and we need to use and we need to deploy a pod or deployment or stateful set or daemon set. But to do that, we need to store some data, for example, and to do that, we need to use the persistent volume claim that to use the volume provision by our administrators. And this PVC, this is the object mount and used to mount the volume inside the pod. So this is very important to know that. And there are some use case to mount with a different method. If you use, for example, a deployment or a stateful set. Stateful set basically is just created to manage this kind of thing, because this is especially created to deploy some stateful application inside Kubernetes cluster. So this is really useful. For example, persistent volume claims have a template of pod like deployment, but aside of it, there is a template of persistent volume claim. We will see that in the next video. Of course, you need, when you are administrator, when you are developer, to like the administrator on the persistent volume side. In the persistent volume claim, you need to use or to set the manifest about the persistent volume claim, and in the specification, you need to set how many volume disk size that you want to use, and you need to use it from a dedicated persistent volume. The access mode too, of course, you can't and you need to use that what you have inside the persistent volume, and sometimes, and maybe always, a storage class. We'll see that just after. What is it? What is the storage class? Basically, that defines some specification, and like the name means, it's a class, like a class, for example, in Python or other language. That means that you have an object, and you can instantiate this object to use automatically some persistent volume, not persistent volume claim, but persistent volume directly without to create the persistent volume. And this is really useful in when you have a cloud provider, for example, because the cloud provider don't provide the persistent volume, but provide a storage class. And through the storage class, you can create automatically the persistent volume. We will see that in the next video. The storage class allows you to create some dynamic provisioning with what we just explained, and that ensures the association between the persistent volume and the persistent volume claim, to be sure to mount the right persistent volume with the right persistent volume claim, of course, to have the same parameter. You can't mount or use a persistent volume claim with a bad persistent volume. For example, if you have not the good size or just the wrong access mode to use it. And one of the purpose about the storage class is to provide a name, and with the name you can, for example, provide to your developers a class of storage. For example, you have a slow storage, maybe with a physical disk and legacy disk. Maybe you have a quick or SSD storage to ensure that you have high performance. You can have a standard storage, maybe just because we just provide only one storage class. So, just to begin, we have the persistent volume on the left, we have the persistent volume claim on the right, and like you see, we have a manifest. For example, here we have the kind persistent volume, and we have we can, like an administrator, we can set the name of our persistent volume, like a standard 5 gig of size, and in the specifications, we have the capacity about the storage, and in our case, we want to provision 5 gig of disk. Of course, like we said, we need to set the access mode. In this case, we just set read-write once. That means we can only mount this volume one time on a node inside the cluster. You can mount it, of course, on another node one time too, and in the same time. And we need, as a developer, a persistent volume claim. Of course, we for example, we can imagine that we have a pod, and we need to mount inside the pod a specific volume. And to do that, we create a persistent volume claim with a specific name. Sometimes the name is associated with the name of the pod or the deployment or maybe the stateful set. And we set some specification. So the access mode, read-write once, and the request storage. You can see this is a request. So we need to find 5 gig of size disk. And how Kubernetes works by default, if you don't use the storage class, basically Kubernetes try to associate the access mode and the size that we can use inside and what we can provide inside with the persistent volume, and associate which PVC can be associated with the right persistent volume with the same specification, especially for access mode. Here we have read-write once. That means that this PV can be used because we have read-write once here too. And of course, the storage is just so the persistent volume storage here is 5 gig, and it's upper than 4 gig that we have that we want to use. And it's okay, in this case, automatically Kubernetes can associate PVC and PV. But how we can handle multiple PV, because I am an administrator and I want to provide to my developer many persistent volume with, like we said, for example, we can have a persistent volume dedicated for SSD and for physical disk, etc. This is where we can use the storage class. And in this case, for example, we can, on the left, like previously, we have the persistent volume, exactly the same thing, but we specify here that we have a storage class named standard. That means that before we can create a manifest dedicated to create a new storage class like this one with the name standard. We have some specification about this storage class for the binding, for example. That means that the storage class is just activated when we have the first consumer, so the first pod, which will use it, of course. And we can specify here the reclaim policy here. So we set it to retain. We have retain, delete, and reuse. Okay, and with that, how we can handle that? We can create the PV like that. We can create the storage class like that. And if we have multiple persistent volume here, we can create multiple storage class. And of course, to use it, we can create a persistent volume claim here. And we can use, like previously, exactly the same manifest, but we can set exactly the storage class that we want to use with the storage class name. And if we set standard here, automatically Kubernetes just bind this storage class and of course this persistent volume directly with this persistent volume claim. And it's cool, but it's quite harder, of course, because you need to declare or to set to create a persistent volume, you need to create a storage class, and also you need to create a persistent volume. This is where the dynamic provisioner and dynamic provisioning is really, really useful. So we can imagine that we have, for example, multiple persistent volume and multiple persistent volume claim, and we can associate it like we say with the storage class. But with the dynamic provisioning, it's done dynamically, like the name said. How it works? So this is exactly like a controller inside your Kubernetes cluster. What is a controller? Remember, a controller is just an application, a dedicated application inside your Kubernetes cluster and deployed for the specific usage to just listen and watch storage class list and discover some storage class that this application can handle automatically. And this part of code is mounted with a service account just to watch storage class, for example, and can be connected to some other application or API, an external application about your Kubernetes cluster, like for example an API from your cloud provider, for example, a dedicated API to manage the disk provisioning that you can have EBS on AWS or stuff like that inside Google Cloud or Azure or some other cloud provisioner. You can use it also to create dynamically NFS with a NFS server, and we will discover that in the next video. So how it works? The first thing that you need to do to do that, you need to deploy, of course, the provisioner. So this is like a controller. So this is an application inside your Kubernetes cluster. This application watch permanently the storage class that this specific provisioner can handle. And when you create a new PVC, you just set a storage class that you want to use. And if this new this storage class is provided aside of the provisioner, and when you create a new PVC, you just set the storage class name to use this dedicated storage class, and of course the provisioner can just discover the change that you want to use the storage class and take your specifications inside your PVC, for example, the volume, the read-write, etc., and use it to provision that what you have just after the provisioner and what the purpose about your provisioner to use it. So for example, a cloud provider provisioning or NFS, etc. We will see in the next video a little demo about all these things, of course. So don't forget to subscribe to the channel to not miss this video. And you can, of course, just discover many videos on the homepage about the Xavkey channel. And see you in the next one. Bye bye.